Welcome. Dear students, today we are going to discuss on free radical substitution reaction of alkane. Free radical substitution mechanism is seen in halogenation of alkane. To understand the mechanism, to understand the reaction, let us first study the structure of the smallest member of alkane, that is methane. So here I am going to draw methane. See, look at the atoms with which methane is made of, carbon and hydrogen. There is no significant difference in electronegativity. They are having the same electronegativity, carbon and hydrogen, and because of which the electron cloud is uniformly distributed around carbon and hydrogen. The electron pair, most of the time, it is at the center. So the molecule is very stable in itself, right? And because it is very stable in itself, it is very unreactive. Why I am saying it as unreactive is because if you are reacting it with a polar molecule, it won't develop charge, it won't ionize. So ionization is prerequisite to undergo reaction, to do reaction. So it won't ionize like that. An easier way with which this would react, the methane molecule would react, is halogenation of alkane. Okay, it is by free radical mechanism. That is an easier way for the methane to react. That is the option for methane to react. So alkane reacts with free radical substitution mechanism. That is seen in halogenation of alkane. So now the question before us is, what is the halogenation of alkane? Okay, so we will see the reaction. Halogenation of alkane is a multi-step reaction. It consists of 4 steps. Okay, what happens here is alkane is treated with chlorine in presence of UV light, sunlight. You can expose it to sunlight, or in presence of UV light at 200 to 300 degrees Celsius, and that would result in the first product, which is CH3Cl monochloromethane and HCl. So that is first step. In the second step, what would happen? CH3Cl would react with chlorine in the system, in the reaction system, and it would yield dichloromethane plus HCl. The second step. Now in the third step, the dichloromethane that is formed, CH2Cl2 that is formed, it would react the chlorine in the system, in the reaction system, to form CHCl3, that is chloroform. In the fourth step, CHCl3 would react with chlorine and it would form CCl4 plus HCl. So as I have mentioned earlier, it is multi-step synthesis. That is, there are 4 steps. To be very accurate, it is made up of 4 steps and 4 products are formed, and these are polysubstituted halogenated products, right? These are polyhalogenated alkanes. So we get a 4-step reaction in which polyhalogenated alkanes are being formed. To understand the reaction, to understand the mechanism of this reaction, we will have to look into the mechanism. I already told that this mechanism is free radical substitution mechanism. So we will look into that mechanism now. Mechanism. The mechanism consists of 3 steps. How much steps? 3 steps. Step number 1 is chain initiation step. Chain initiation step. Okay, let's see. Initiation step. Now what happens in this step? Let's see. See, we have taken chlorine, right? We write chlorine like this and we expose it to UV light. Okay, we expose it to UV light. Homolytic fission of chlorine occurs. Homolytic fission, that is, each atom gets 1 electron. Okay, homolytic fission of the chlorine molecule occurs. So now free radical has formed. Okay, now this free radical is the most reactive entity in organic chemistry. It is more reactive than an ion. So it won't leave whatever it is before it, it would try to take an electron from that. Okay. Step number 2, chain propagation step. Chain propagation step. Propagation step. Let's see what happens in this step. So what did we form in the first step? Yes, we formed chlorine, right? It's in the test tube, right? This chlorine now reacts with methane. I have written methane like this, CH4. I have written it like this. Now this chlorine, what it wants? It wants one electron. So it takes the electron from this molecule, okay? But with electron it takes the H also. So now what we get is CH3 free radical and HCl. So what we have seen is the chlorine free radical which we have obtained on homolytic fission of Cl2 by exposure to UV, that has taken an electron from methane. With the electron it has taken the atom 2, and now we have formed a new free radical is formed. This is methyl free radical which is formed. Do you think the methyl free radical will sit like that? No, it's also very reactive, being a free radical. So what it would do, it would take an electron from the chlorine molecule which is in the system. It is also in the system, correct? So it would take that electron and they will form one entity, CH3Cl, and we get chlorine free radical here again. Now this chlorine free radical, what it would do? It would again react with methane, and again methyl free radical will be formed. This methyl free radical will, what it will do? It will snatch an electron from chlorine. Along with it, it will snatch chlorine atom 2. So methyl chloride is formed. Again chlorine free radical is formed. Again chlorine free radical will react with methane. Methyl free radical will be formed. Methyl free radical will react with chlorine. Monochloromethyl will be, methane will be formed. Monochloromethane will be formed. So in this way this step will continue like a cycle. It will keep on going, keep on going, keep on going. Okay, and till the time when this monochloromethane, its concentration is high. Okay, when its concentration becomes high, the probability would be that this chlorine free radical would react with this. Am I right? When the concentration of this becomes low and when the concentration of this monochloromethane becomes high, then the possibility of Cl free radical, rather than attacking this, it would attack this more. Am I right? Yes. So we are going to see step 2 of multi-step reaction. This is step 1. What we formed here, monochloromethane, right? Okay. I am writing that. Let's go to the formation of dichloromethane. As I said, when methane concentration become less and when monochloromethane concentration become high because of this cycle, the next probability of Cl radical will be to attack CH3Cl. So what happens here? I am writing CH3Cl like this. Okay, it's one and the same thing. I have written the H here. Now Cl wants an electron. It takes an electron. H also. Okay, it wants an electron. With it electron, it will take the H2, and what we get is this and HCl. This is monochloromethane free radical, right? And this monochloromethane free radical, it would react with Cl2, which is already in the reaction system. This won't sit idle. This is also a free radical. It wants an electron, so it would react with chlorine in the reaction system. So chlorine should be there excessively, correct? If it is not there, then it would end. It would not propagate. So chlorine should be there excessively. Please note that. And what would happen? Yes. So now we got CH2Cl2 plus Cl free radical. Now we have done the second step. This is dichloromethane. Dichloromethane. So what we have seen here is that the Cl free radical, which was formed in the first step, now it reacts with this and it forms a monochloromethane free radical. The monochloromethane free radical now reacts with chlorine molecule to form dichloromethane and Cl free radical. The Cl free radical will again do this. Am I right? And then again it will do this thing till a sufficient concentration of CH2Cl2 is now in the system, right? So when dichloromethane concentration increases, the Cl free radical, rather than attacking monochloromethane or methane, would attack CH2Cl2. So that is what we are going to see in step number 3. That is third step of the reaction. What is that? CH2Cl2 Cl free radical, because now dichloromethane's concentration became high, it will react with dichloromethane. This is same thing, dichloromethane. Now let's see how the reaction proceeds. It wants an electron, with electron it takes. Now we got dichloromethane free radical, right? This dichloromethane free radical, it would react with ClCl, and what would happen? Yes, CHCl3 will be formed. It will be formed, pardon me. So now this is trichloromethane or chloroform, right? So now this is the third product that is formed. What happened? When dichloromethane's concentration rose, then Cl free radical, rather than attacking monochloromethane or methane, attacked dichloromethane. It took an electron. With electron it took the H atom, and we formed a monochloromethane free radical. This dichloromethane free radical. This dichloromethane free radical reacted with chlorine molecule, and the result was that we formed chloroform, and chlorine free radical was again formed. This cycle will get repeated like this till a sufficient concentration of CHCl3 is in the system. Correct? Now Cl free radical, what it will do? It will, rather than attacking all the other two, that is dichloromethane free radical, monochloromethane free radical or methane, it would go for attacking CHCl3 because that is there in the system more. Right? So I am writing it like this. Fine, this is one and the same thing. Now how it will proceed? Yes, in this way. So we get trichloromethane free radical and HCl. This trichloromethane free radical will now react with Cl. As I said, chlorine should be there excessively in the reaction system, otherwise these products won't be formed. So now what happened? CCl4 and Cl free radical. And now again this will continue like this till a sufficient concentration of tetrachloromethane or carbon tetrachloride is formed. Carbon tetrachloride. So this is the 4-step reaction. What did you observe in this? First thing that we have observed is that hydrogen free radical has been substituted by chlorine free radical. In whatever we have seen in chain propagation, whatever we have seen for products, for formation of 4 products, what is the common thing? Hydrogen free radical has been replaced by the chlorine free radical. So this type of substitution reaction where one free radical replaces the other free radical is called as free radical substitution reaction. The second thing that we have observed is we formed a polyhalogenated alkane, right? And there were number of polyhalogenated alkane. It was not one or there were 4 actually. 4 polyhalogenated alkane we have formed. And one more thing is that we have used chlorine in excess so that the reaction goes like this, right? So these are the 3 things that we are seeing. Now there will be a time when all these products are formed and Cl free radical could not take an electron from this. In that situation, what will happen? Step number 3, chain termination reaction. What is it? Chain termination step. What happens in this step? A Cl free radical collides with another Cl free radical and forms the Cl2 molecule. Or in some case the CS3 free radical that was formed in the first step, it can collide with CS3 free radical and it can form CS3 ethane, right? So these are the 3 steps. I hope you have understood. We have seen that in free radical substitution mechanism, one free radical replaces the other free radical. In this case, halogenation of alkane, we have seen how a halogen free radical has replaced a hydrogen free radical to form 4 halogenated alkanes, right? And 3 of them were poly halogenated, correct? So we have seen this, and we have also seen that it takes place in the presence of sunlight. If sunlight is not there, or if UV rays is not there, this homolytic fission would not have occurred, correct? So these are the points that we have to note in this. Now we are going to discuss drawbacks of this reaction or limitations. See, we get polyhalogenated alkane, polysubstituted or polyhalogenated alkane. Our intention was to get maybe one haloalkane, but we get polyhalogenated alkane, correct? So it is not useful for us to make haloalkanes because the 4 haloalkanes that we got are in low yields, correct? They are in very low yield. So it is not at all useful for us to go for this reaction in order to prepare haloalkane. There are better methods than these, and this reaction is not under control, correct? It does not have any control. Am I right? We cannot control this reaction. That is why these 4 products are formed, and it's very difficult to separate the 4 products. So the atom economy of this is very, very less. Okay, the atom economy, the yield that we get for each product is very less. So that is the first limitation, polyhalogenation. That is 4 products are formed, 4 polyhalogenated alkanes are formed, which has that too in low yield. Thereby atom economy is very less, that is the yield that we get per gram of the product is very less, and it is not at all useful for making haloalkane. That is the first thing. The second this thing is, have you noticed that in the chain termination step, CS3 combined with CS3, right? And it can form ethane, right? So this is absolutely not needed. This is actually an impurity in the reaction. So ethane is impurity in the reaction. That is the second limitation. The third limitation is, it is okay with your methane and ethane, but what about propane? If propane is to react, how will it go for reaction? I mean, which hydrogen would it take? If it takes this hydrogen, it's fine. It will, one can have one haloalkane. If it takes hydrogen from here, we get one haloalkane. But if it takes hydrogen from here, we get 2 haloalkane. So actually for propane, we will get isomers. Am I right? Isomers of haloalkane. And that would be very difficult. It is actually not possible to separate isomers. Fine. So for propane, for methane, ethane, it's not an issue. But for propane, there are 2 types of hydrogen atoms, and if chlorine replaces these, we can get isomers of haloalkanes. So that is the third limitation that we face. So dear students, that ends that ends free radical substitution reaction. Now there is one more thing that I want to tell you, that free radical substitution reaction can take place in dark also. It can take place in dark also, but for that you have to use benzoyl peroxide as catalyst. Let us see what happens if you are using benzoyl peroxide as catalyst. This is benzoyl peroxide, okay, and this actually splits from here and we get free radical, and that free radical is like this, C6H5 C double bond O, right? This is the lone pair and this is the free radical. This is the electron that is of interest. Okay, I am going to redraw this structure like this. C6H5, okay, that's bond O and O. I am writing this free radical down, and lone pair I am writing it here. So this can go here and this would go here, it would form a bond, and we get C6H5 free radical plus CO2. Now this C6H5 free radical, it can react with chlorine in the test tube, fine, and what it can cause, it can take homolytic fission, it will cause a homolytic fission, right? And what we will get, chlorine free radical and C6H5Cl. Now we have got Cl radical, chlorine free radical. Now it can react with CH4, correct? And that can result in CH3Cl plus HCl, fine. So now we see, right, CH3Cl it can react. So now we can see that if we are using benzoyl peroxide catalytic amounts, we can perform this experiment in dark also, correct? There should be chlorine in the system, there should be methane in the system, need not be UV, okay, it need not be UV. You can put catalytic amount of benzoyl peroxide, that benzoyl peroxide free radical, it can cause homolytic fission of chlorine. So it also, you can say, this is also proof that the mechanism takes place by free radical, that the mechanism of the reaction is free radical mechanism, correct? Because usually in dark it is not taking place, correct? Because chlorine does not form free radical in dark, okay, it only forms free radical in light. So to prove that actually free radical is involved, we use peroxide. Okay, so this thing is proven that peroxide, if it is there, it reacts with chlorine molecule, free radical is formed. So it's actually a proof that the reaction proceeds through free radical. And secondly, it is also shows that this reaction can be carried out in dark if catalytic amount of benzoyl peroxide is used. Dear students, I hope you have enjoyed the class and you have liked it. If you do understand the class, please do not forget to like, share and subscribe this video. Thank you very much.